In this lesson, we are going to discuss the standard input, standard output, and error output. So, whenever you start a program on Linux and the program returns something, then the result is usually presented on the screen. Why? Because every program started on system has its standard output, and normally this standard output is the screen. But this can be changed. Look at this example. I want to find in the etc directory and its subfolders files with extension conf. My screen is now full of messages related to found files. However, when you look on the screen closer, you will see that sometimes there are errors permission denied. Well, this is an error, but for the moment let's ignore this problem. If I would like to have the result of the find command to be saved in a file, then it's enough to add the redirection character and the file name. Now the results should be directed to the file. On the screen I can read a lot of error messages, but indeed my command was started without sudo, so I don't have access to all the directories, and the errors are, let's say, correct. Anyway, on a disk there is a file with the results of the find command. It looks quite good. I was able to redirect the output to the file. Now the file size is about 4 kilobytes. If I would start the command once again, the previous file content would be replaced with new content. As nothing was changed on the system, the file size remains the same. I may, however, wish to append the results to the file. Instead of a redirection symbol bigger than, use a double symbol. Currently, the file size is twice so big as before. You have seen here how to change the standard output into a new file or append it to an existing file. However, there are still many errors on the screen. Let's try to do something about it. I will add to the command following expression: to redirect to find errors.txt. What will happen? The number 2 designates the standard error output. Indeed, every program running in Unix has also standard error output, where all the errors are sent. Normally, this is again the screen. You may want to redirect the errors to another device. In such case, you can point that 2 should be redirected somewhere else. So, when displaying the file find errors.txt, I will see here the error messages that previously were displayed on screen. If you are concerned about the parameter 2, then maybe everything will be easier to understand if we note that the standard input has assigned number 1, so the command could be changed to a bit different format. The standard output 1 should be redirected in one file, and standard error output should be redirected to another file. Well, I think that skipping the value 1 was a good idea. But with your commands, you will decide. From time to time, you may want to save the standard output and standard error output in the same file. In such case, you can use another notation. The error output 2 should be redirected to the same place where standard output 1. Now in the file find results, I can read the correct results generated by the command, but also any potential error messages, all in one file. As a user and also as an administrator, surely you don't like when the commands throw errors on screen. As a perfect admin, you may want to hide all the errors. In such case, you may destroy, hide all the errors. To destroy information about errors, send the errors messages to def null. The def null is like black hole. Whatever will be pushed there, it will disappear, does not exist anymore. Of course, sending always all the errors to def null is not the best practice, because you lose information related to potential problems. You may be unaware of them, so don't abuse. The same trick could be used with a command generating too many messages. If they are not interesting for you, throw them away. Apart from standard output and error output numbered as 1 and 2, we have also standard input designated with number 0. We will see in a moment how to redirect standard input, but now we will take a closer look to the read command. I will create a script named tell me. This simple script will display prompt enter directory name. The user will need to type on the keyboard the name of a directory, and after he or she presses enter, the value will be saved in the variable name. In the next line, the script will ask user for a file name. The entered value will be saved in the variable file. Next, the script will display the data on screen, and that's all. When I start the script, I'm asked for a name of a directory, and after it, for a name of a file. Finally, the script displayed the entered values, and that's all. Now, let's imagine that we are developing a script that will use another script developed by other programmer who constructed the script so that it is interactive. It asks for some values, just like we did it here in the script. Unfortunately, our script should work in batch mode without any interaction, fully automatic mode. How to deal with it? Well, we need to develop another script that will talk with this interactive script. It will be talking with the interactive script in automatic way. Let's name it tell him. In the script, we will call the script tell me, but in this case the standard input of the script should be taken from my current script, not from keyboard. We will use a redirection symbol again, but this time the brackets, arrows are directed in reverse direction, less than, less than. Here we can use any text. Often it is end of input, but this can be whatever. That needs to be just a text different from all the other texts below. Why? Because when the script will find this text, end of input, it will end reading input for the script tell me. In this case, when the script tell me stops and asks for the catalog, it will get it from the current script. The given directory name will be etc. When the script stops again asking for file name, then it will get password. And this finishes input generation for the script tell me. We don't need anything more for this test, so we will just display text done and the script tell him will finish. Let's see this in action. We will call tell him. Internally, this script calls tell me. All the interactivity of that script will be handled by the script tell him. The both scripts were run, talked to each other, and no additional questions were asked to me as the person starting the script. As a consequence, this script could be started in batch mode without any interaction. Another example of using this construction could be done by creating a dedicated file with all the answers. Here, I will create a file named info.txt. Here I will add two lines, one with directory name and the other with the file name. By the way, look at the command cat. This command is also interactive. It asked me for a file content. However, the standard output was redirected to the file. So all the entered by me lines of text are saved in the file. Having this file, I can call the interactive script tell me, but the standard input will be changed to the file info.txt. Now the script tell me talks with a file, reads the values from the file, and after it executes next lines of code. In our case, only displays a message. In this lesson, we were able to see how to work with standard input with descriptor 0, standard output with descriptor 1, and standard error output with descriptor 2. We were able to see what is a file def null and how to combine standard output and standard error output into one file. Now you are able to control values displayed by the commands according to your wish.